Hello and welcome to Amomii's Coding Colors bonus lesson 2. I'm Sean, and in today's lesson I'll be showing you how to build the amomii glow box, modify code from the previous lesson to work with it, upload cool example animations, and how to scroll text. So let's get to it. The materials for this lesson are pretty much the same as the ones used in bonus lesson 1, only the template is different. To refresh your memory, you'll need an amomii glow kit, including all of the wires it comes with, a microcontroller, a computer with the Arduino IDE installed on it, 2 sheets of cardboard A3 or bigger, access to a printer that can print A3, wide double-sided sticky tape, a sheet of white printer paper, a sharp knife that you can use to cut the templates, and that's about it. Again, if you aren't an adult, make sure you get help from one when cutting the templates. Like I mentioned last time, I am using the amomii Uno, which can withstand a higher power draw than most other versions of the Arduino Uno R3. So, external power supply might be needed if you aren't using the amomii Uno. There are details on wiring for that in the amomii Glow Getting Started manual. You can see that on the website. Alright, let's get it built. On the lesson page, you'll see a link to the templates. Download it and you will find 2 PDFs, amomii Glowbox Box and the amomii Glowbox Diffuser. These templates are for A3 paper. When you print them, you must print them at the original size with no borders or margin. Stick the templates to the cardboard using double-sided tape. Be sure to cover the back with as much tape as possible. That's why wider tape is a good option. Cut out the templates. Note that the red lines indicate where to cut, the dashed lines show where to bend, and the solid blue lines show where to mount your equipment. Cut the white paper and stick it to the underside of the amomii Glowbox diffuser. Be sure that it completely covers the window. Make the box and stick the sides, but leave it open. Secure the microcontroller in the box, being sure to align the USB-C port with the hole. Put the 8 glow strips in position. It is important to orient them correctly. The arrows on the strips in the first column must be pointing up, pointing down in column 2, up again in column 3, and so on. Basically, you should be able to follow the arrows with your finger from the first pixel to the last, going up, down, up, down. Next up, you must wire them. You should follow the wiring diagram to make sure that it is correct and double check it before powering the project up. But basically, you connect the input of the first strip to the microcontroller, with the ground going to the ground of the microcontroller, 5 volts going to 5 volts, and the signal pin connecting to the digital pin 9 on the microcontroller. Then connect each strip one by one, following the arrows, with the output of the first strip connecting to the input of the next, making sure that the ground is connected to ground, 5 volts to 5 volts, and signal to signal. Note that the first strip is bottom left when looking from the top, but bottom right when looking from the inside. This is the one that connects to the microcontroller. Again, double check everything before proceeding, as bad wiring can damage the hardware or even overheat and cause injury. When all looks good, you can run the test code. I definitely recommend running the test code before sticking the box closed, just to make sure it's working. You can download the test code from the lesson page. Download the code file, unzip it, find the CC Bonus 2 folder, and open the code inside. When the Arduino IDE opens up, select the correct COM port and board, then hit the upload button. If all is correct, the light should start glowing beautiful patterns like this. If yours are working, proceed to the next step, but if not, run through the wiring again and give it a try. Now, stick the box closed and find the correct height for the diffuser. The closer you mount the diffuser to the LEDs, the greater the separation between the pixels will be. But if you mount it far away, the colors will blend together. For this, I recommend sticking it with a small amount of tape, so you can adjust the distance for different projects. For example, with light patterns, having the diffuser far away creates a beautiful blend of colors, but close up is better for text as the words are more clear. With the glow box built, let's move on to the code. So the first thing I want to teach is that the example code that you just uploaded to test your circuit is basically just the same code from the previous lesson, just modified. To prove that, let's just upload the bonus lesson 1 code, and then we'll upload that and modify it, and we can see what it looks like before it's modified, and then we can see how it changes. Okay, so I've already got my glow box set up here, ready to go. Let's do it. So I've got the CC bonus 1 code. I've opened it up. And to start with, I'm going to make no changes. You can see, you probably recognize all of this code set up from before. And when I plug this in, you can see right now, one good technique is maybe to just open the ports here. And if I plug in at the top, you can see COM17 shows up. I'll make sure that one is selected. It says Arduino Uno, so I don't need to change that. And then if I hit upload, the code from the previous lesson should upload to the new setup. Let's see how it looks. And you can see it looks pretty good, but it's not the way it's meant to look. You can see that's actually going in stripes. So basically what's happened is we've got this long tower and we've kind of broken it down. So we've got this cool pattern happening, which looks pretty good, but it's not what we were trying to achieve. So we need to fix it to make it the way it's supposed to be. And that is super simple. All you have to do is change the rows and columns. So previously we had 16 rows and we just had 4 columns, but now we've got a grid of 8 by 8. So we just simply change this to 8 by 8, upload the code again. Oh, before we do that, we should go File, Save As. So remember, never make changes to a previous code. You should always do the Save As first before you upload it, or you lose the original code. So we'll call this CC Bonus 2 Custom, for example. Any other name that you haven't used is fine. And save that. All right, that's great. Now that it's saved, I'll just hit upload. Now you can see it's filling up, filling down, doing the straight lines up and down. You can see it's working perfectly, just how it's supposed to. Okay, now just like in the previous lesson, we could customize this code. Let's say, for example, you just wanted to do the hoop up and hoop down. We can go down to our loop. We could just highlight anything we don't want and comment it out. Comment all of the others out, for example. And then let's say you just wanted to hoop up and hoop down using these different effects that we talked about in the previous lesson. We upload it now. You can see it's just doing this now. And this code here is making it go through the hues. As we loop around, the hue keeps changing. That's why the color's changing. So you can see you can do that. You could use any of these different features that we used in the previous lesson. Exactly the same. The only thing we needed to change was the rows and the columns. Super simple. All right. Excellent. So that's pretty easy. So let's move on to something completely new. So the next thing we'll look at is how to use one of the fast LED example codes, which creates this really cool kind of spinning light pattern, which looks excellent, but you do need to modify the code a little bit to make it work for our setup. So I'll teach you how to do that. So if we go to File, Examples, you can see I've got lots of different libraries here. You probably won't have that many if you're new to Arduino, but you definitely have this one, which is the Fast LED library. So if you go to Fast LED and you scroll down to XY matrix, it's going to bring up this code. Now, if you look, it may look intimidating and long and complicated with loads of words, but actually most of these words are comments. They're notes for you to read. So I do encourage you to read through all of these if you want to know a bit more about how the code is working, but I'll tell you exactly what you need to know for our particular project. So we need to modify a few different things to make it work. First of all, define the pin. Our matrix is connected to pin 9, so we'll change that to 9. The color order is green, red, blue. It's the same as ours, so that's fine. We can change this to WS2812B. That's the chipset of the amomii Glow pixels. That's what they use, the WS2812B chipset. Brightness 64, I'm happy with that. Maybe I'll make it a little brighter for the video. Try 80. If that cuts out, it's probably because it's trying to draw too much power from my computer. So if it does cut out, then I'll bring that power down. All right, next one. Matrix width and matrix height. We know that the width of our matrix is 8. The height is also 8. Okay, now it's got some information here. You can see that there's different ways of setting up of wiring a matrix. So we have two different types of layouts. We have one where the pixels follow each other in a continuous flow like this. And then we have vertical where they go in straight lines like that. So if you recall when you built your circuit, the arrows on the amomii glow, they kind of follow this continuous path from the first pixel to the last one. So we are using the serpentine layout. Okay. So for now, this is correct for us. Serpentine is true. Vertical is false. Okay, so we're using serpentine. There's more information that you can read about this if you want to, but I've kind of just told you all you need to know. Some bonus vocabulary for you here as well. I'm sure if I tried to pronounce this, I would make a mess of it, so I'll skip over it. All right, wonderful. All right, is there anything else I need to change? Potentially not. Let's upload this and see how it looks. Now you can see this awesome spinning pattern, and that's just beautiful. And it's very little work from us. All we had to do was change a couple of the variables, and it's working like this. Now, if you built yourself a matrix which was much bigger, but you wired it up the same way in the serpentine pattern, all you would need to change is the rows and columns, just like we changed bonus lesson 1's code to work for bonus lesson 2. All you need to change is this information here, and this beautiful pattern would work on basically any size of matrix that you built. Obviously, you would need to consider how much power is being drawn though, and if you need to use external power supply or not. You can find information about that in the Getting Started guide with the amomii glow. All right, that's it. So that's a pretty cool effect. We're going to move on to our last thing that we're going to learn, and that is how to display text. We'll start off with an example code, and then we'll modify the text to display anything you want. I'm going to display coding colors. Okay, so to display text, we're going to use a different library that you don't have. So we're going to have to go over to the library manager, which is on the side here, the one that looks like a stack of books. In the search bar, we can type in Adafruit and then _neo matrix. Okay, so you can see that mine has remove. In fact, I'm going to remove it so then I can install it again. And you can see when you hit install, it's going to come up with this, which asks you, do you just want to install without discrepancies, or do you want to install all? So basically this means, do you just want to install the Adafruit NeoPixel library, or do you want to install the NeoPixel library and the other libraries that this library depends on? So in other words, this library is using functions from other libraries in order to function correctly. So you're going to have to select install all, otherwise it will not work properly. So install all, and after a few moments, it should say successfully installed. All right, so now that you've got the Adafruit library downloaded, you should be able to find it in the examples. So let's go to File, Examples, and scroll down until you find Adafruit Neo Matrix. And then one of the options inside of there should be Matrix Test. Select that one. All right, we need to make a couple of changes so we can upload the example code. And once we've done that and we've made sure that everything's working nicely, we'll look at how to edit the example code and customize it. All right, so pin, our matrix is connected to pin 9. Now underneath here is all of this information. This information is all about matrix declaration. It's about you providing the code with information about your particular setup. And here's where you put it all inside the parameters of this function. Okay, so this is the Adafruit Neo Matrix function, and it expects all of these parameters. So you need to fill them in. So let's find out what they are. So we've got parameter 1 and 2. Up here it tells us parameter 1 equals the width of the matrix, and parameter 2 equals the height of the matrix. We know that ours is an 8 by 8 matrix, so we will put 8, and the second one is already 8. The next piece of information is the pin. We already changed that to pin 9, so we can leave that alone. Next, it's asking for the location of the first pixel in your matrix. In our case, that's the bottom left, because we're the one that's connected to the microcontroller is the bottom left, and then the arrows go up and down like that. So we can change this from top to bottom, all capitals, and we can change right to left. Next one, it's talking about whether or not your strips are connected in columns or in rows. In our case, we connected it in columns, so we don't need to change the example one. Next, it is talking about the order of the pixels. Are they going in a continuous line like this, or are they going in the same direction? In this case, progressive means the same as vertical in the previous one, and zigzag is the same as serpentine. We used serpentine in the previous one, so you know that we're going to use zigzag in this one, meaning that if you follow the arrows, it kind of goes up in a zigzag pattern like that. All right, so we change progressive to zigzag. Next up is the color order. Green, red, blue is correct for us. And next up, the last one here, it tells us it's about the bit stream, so the speed of data transfer. We can see here that it says WS2812, and that's what we are using. So kilohertz 800 looks good for us. And that's what it's already set as, so we don't need to change that one. Okay, with all of these changes made, we can upload it and see if it's working correctly. And you can see the words howdy. And they change color from red to green, and then finally to blue. And it just keeps repeating the same word. Now, if that's not very clear, perhaps I can try and move my box a bit further down. Like I mentioned, the closer this is, the more you can see the separate pixels. Let's get it nice and close for this example. There you go. So now I've moved my diffuser down. It's nice and clear. You can see the pixels. The further away it is, the more blurred they come. So I always find for patterns, it's nicer to have the diffuser a bit further away. For words, a bit closer. Maybe I could split the difference, but this is nice and clear, so I'll just leave it as that for now. So let's look at the code and see how it's working. You can see here we've got an array called colors. And if you don't remember, an array is kind of like a list of information. And it's all contained within these curly brackets. I'm going to put this curly bracket on the next line just to make it nice and clear. So you can see inside of these curly brackets here, we have some information separated by commas. Now we can see that it's going from red and then green then blue. So we can probably guess, as this is 25500, this is 02550, 00255. We can probably guess that this here stands for red. So if this is RGB, full brightness on red, 0 on green and blue. This one, full brightness on green, 0 on red and blue. And then this one must be blue with 0 on red and green. So we could say that the color in this array, colors, in the first position, which is actually position 0, we've got red, position 1, green, and position 2, blue. Okay, so in the setup, we've got matrix begin, which is initializing it. We've got something called text wrap that we're not using. We set the brightness. I find that 40 is fine. And we set the initial color. So it's saying matrix.setTextColor, and it's setting the color to whatever color 0 is. So if we go back up here, here is the colors array. In position 0, it's this one, and we already established that that is red. So the initial color when we first turn this on is going to be red. All right, then we have a few variables. We've got a variable called x, and it's saying that that equals matrix width, and we've got a variable called pass, and that equals 0 right now. So we'll not worry about that until we've looked at the main code. All right, so let's take a look at the loop and see what you need to change in order to customize the display. So you don't need to understand every single part if you're new to coding. but we'll just talk about the various things that you need to change if you want to customize your own. All right, so we've got fill screen. This basically just clears the screen. You don't need to touch that. We've got here, which is the coordinates of where the words go. So basically, if we just change this to 0, for example, and we upload this code, you can see that your word is right in the position here where the display is starting here. Let's see if I move it over. This is the X here. If I move X over to 4, let's see what happens. Upload that. It should start somewhere over here. All right, so you can see that by changing this parameter here, we change the position of the word. So by changing X, we can make the word appear to be moving. Okay, so let's put this up here. Okay, and that has it moving. Now, basically down here, this may look confusing, but this is just a shorthand way of saying, let's try making it in a way more similar to what we've done. So if we just say every time around, we go X minus minus. So X starts as matrix width, which is 8. So it's going to start off the screen. And then if we keep going minus minus, it's going to keep going that way. So it's going to be 8, 7, 6, 5, 4, 3, 1, 0, and then eventually into negative numbers. Okay, so the word's always going to start being printed either from off the screen over here or all the way down here. So if we say it starts, let's even just make it very clear for ourselves. Let's just say it starts at 8. And then each time it loops around, it goes from 8 and 7 and so on. But then we say, if X is less than negative 36, so if we keep going negative, 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 till we get to 36, that means the word's getting printed all the way over here. Then we reset it back to 8. So then it equals 8 again, so it resets it again and does this. So basically, we start from 8, and we keep going backwards to negative 36, and then once we get to negative 36, it resets again to 8, and so on. So let's see if it still works. And you see it's working quite nicely the way it was. So that's this, the way it was set up is just a shorthand way of writing the way it is now. All right. And this one here, so every time, so basically every time we reset X back to 8, reset the word being printed off the screen on this side, each time we do that, it wants to change the color. That's why every time it comes off, it starts again as a new color. And the way it's doing that is by using this function, which is set text color. And it's saying from the colors array that we set up, entering the number pass. So we can reformat this if statement into one that's more familiar to us. Again, we could just say, take that away. We could just say pass plus 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 plus. All right. Like that. So the way it was formatted just before was exactly the same function, it just different formatting, a bit more of a concise way of putting it, right? But it means the same. So basically, when we come into this if statement, it checks. It says pass plus plus. So pass started off as 0. The next time around, it will be 1, and then eventually it will be 3. Eventually, it will go up to 4. But it says, look, if pass is greater or equals 3, let's change it back to 0. So this pass is going to go 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, which is perfect because that's how many colors we've got. 0, 1, 2, 0, 1, 2, and it will carry on like that. All right. So there we go. Now we know what it does. So I'll upload it and see if it still functions in the same way. So now we know what it does. it should be easy for us to edit. So let's say we want to add a few different colors. Well, we would add these up here. So let's say I want to add, so instead of having 3 different colors, I want to make it so we've got 6. So I can paste this down here. We need to make sure that there's a comma. All right, so all of these are comma separated. So this would be color 0, 1, 2, 3, 4, 5. So we've got 0 to 5. We've got 6 different colors right now. Let's just randomly change these. If you guys could use the website that we use to find the exact color that you want to use, I'll just put some random numbers in here. 200, 200, maybe 20, 100, 200. There we go, something random like that. Or maybe these 2 colors will be too similar. How about 0 and this one 255? So we've got, I've just done the first 3 colors completely different to what they were previously, then it'll cut back to them. So we've got 6 very different colors, but now there's some information we need to change. Now currently, when pass resets itself when it gets up to 3, now we've got 6 colors, we'll need to change this to 6. All right, so let's upload that, and it should now change into 6 different colors. And of course, you could do as many colors as you want to. So now it's this kind of color, got a kind of yellowy color, and we've got this purpley color, then this kind of turquoisey color, and then it'll go back to the regular red, green, and blue. So there we know how to change through more colors now and how to customize them. You just need to get the correct RGB values for what you want. And of course, if you just wanted yours to stay a solid color, you could just comment this whole section out here. Right, make them all comments, so this code has been ignored. And you could just put the color that you want to use. So from your list of colors, let's say I like this second one, I would change this value to 1 in the setup, upload the code, and it will just stay in this one single color. Right, so each time it goes around, it won't change because I've deleted the code or commented out the code that makes the colors change. All right, that's great. So I'm going to leave mine as a color changing one. I want the colors to change. That's great. Next up, let's talk about how to change the word. So here it says howdy. I want mine to say coding space colors. How about we make it longer? Is it's awesome. Exclamation mark. All right, so we've got a much longer message now. Let's check whether or not it works. So we've got coding, coding, So as you can see, it doesn't quite work. The message is being printed here and it's starting to scroll, but then it cuts out and resets too soon. So we need to find the value that determines how long it scrolls for before it restarts. Maybe you should pause the video and try and figure it out yourself and see which value you think you need to change so it keeps on scrolling. All right, let's have a look then. So perhaps you figured it out that it's this one. So we said that it is this variable here, x, that controls the scrolling in the x direction. And we said that each time around this iteration, we go minus minus, so we keep moving it in the negative direction. And it keeps doing that until x is less than negative 36, and then it resets it back to 8, which is just before the screen here. So by increasing this value, we scroll for longer. So it's not quite as simple as just counting the letters because different letters have different widths. So I'm just going to go for the trial and error technique. So I'll just say it's about 3 times more. So I'll say around 90. Let's see if negative 90 is good. But actually, I don't want to have to wait for it to scroll so slowly. I'm just going to speed it up a bit. And the way we speed it up is by changing the delay. So I'll make it double speed for now, just so when I'm checking, it's a bit quicker. So it scrolls a bit faster. Coding colors is, okay, so not long enough. Let's do 145 so we get a little bit of before the next one comes in. Coding colors is awesome. Perfect. We could even make the space a little bigger, but as you can see, the greater this negative value, the longer it keeps scrolling before it resets back to the new one. So basically, if you didn't understand everything, it's not super important, but all you need to know is that the information you need to change to customize yours is you can set your custom colors in here. But if you do that, you'll need to change how many colors that you care about scrolling through in here. You need to change how long it scrolls for, depending on how long your message is. And you write your message inside of these quotation marks. And finally, you set the speed down here. By changing these few different variables, you could scroll any different message you want with certain restrictions. I don't think you could do a full page of a book, for example. But if you've got a little message like back soon or something like that, it would work perfectly. Okay, folks, that concludes the Coding Colors course, but certainly should not be the conclusion of your Coding Colors journey. As your skills and confidence improve, you can try your hand at creating your own animations, displays, and patterns. Try incorporating input devices like buttons and sensors to your projects, or even making games like this Connect 4 I made with a 3D printable case. Speaking of 3D printing, if you have access to a 3D printer, we have some excellent 3D printable accessories for all of our products available for free to download from our website, like these cool daisy chainable diffusers and this nifty print-in-place case for the Amomii Uno. If you enjoyed this mini adventure, you should consider trying out the Mini Grand Mega Kit. With this kit, you get to prototype, code, personalize, and build a fully functional digital instrument while learning a huge amount of skills along the way. It's fun, educational, and leaves you with something to play with and feel proud of. I would like to thank you very much from myself and the whole amomii team for joining us on this course, and hope you got something from it. We would love to hear your thoughts about the course, what you liked, what you learned, or what we could have done better. And please share your creations to the Coding Colors Facebook group. You can find a link to the feedback form and the Facebook group on the lessons page. Thanks again, and see you on the next adventure. Bye.